America is falling way behind in STEM education and STEM proficiency, despite the enormous demand and number of jobs available. Some students just love STEM and science in general, and some could care less. And similarly, some students love to learn, and for others, it's just drudgery. I wanted to know why that is. What's the difference between those kinds of students? I retired from a tenured teaching position to start Science Glen so I could explore just that factor. What's the difference between these students? At Science Glen, we create tools and courses to help people learn faster, easier, and deeper. I have a PhD in anatomy with a focus on cell biology and brain neurochemistry and postdoctoral work in cell biology. During my postdoctoral work at UCLA, I discovered that my true passion was inventing new tools and techniques. So I left academics, started a publishing company, came out with a book called Pocket Medical Spanish that went on to save several lives and was a bestseller. We came out with other books that won awards and did quite well. During the Great Recession, my business failed, so I went back to teaching high school science, biology, chemistry, and physics, everything from the lowest level all the way up to advanced placement. One of the biggest barriers that beginning chem students have is learning the right ratios that ions form between each other when they're forming ionic compounds. Students are baffled by it. When atoms lose electrons, they become positively charged. When atoms gain electrons, they become negatively charged. Positive ions are attracted to negative ions to form ionic bonds. I failed over and over trying to get students to understand this. So I started inventing, and after years of work and testing, I came up with a solution that students really loved, and it worked really well. One single 15-minute training led to a 33 to 44% improvement in understanding. Do you remember any chemistry? Let's see. So, do you know what the formula is for magnesium hydroxide? It's a common chemical. It's often used in antacids such as rolaids. Let's see if you remember any chemistry. Do you remember the formula for magnesium hydroxide? That's one of the ones that students trip over. Let's see what you remember. If you look at the magnesium hydroxide, so we have magnesium. It's a magnesium ion. It loses 2 electrons. You see the 2 pluses, each one because it lost an electron. And then you have a hydroxide where you have an oxygen connected to a hydrogen. And the overall thing is called a hydroxide ion. It has a charge of -1 represented by this minus symbol up there. And for every minus, you have to have a plus, or they hook together like that. And so it's got magnesium, it's got lost 2 electrons, and so it has 2 pluses. So we put all this on. So the formula for magnesium hydroxide is going to be MgOH2. MgOH2. We've created 3 types of the ionic bond disk model kit: basic, intermediate, and deluxe. Due to the large number of molds, many types of ions, and difficulties in putting this thing together, our initial costs are going to be rather high. The molds are finished, and production is about to start. We expect to get final shipment in April sometime. If you pre-order the kit now, you'll be able to get one of these before they sell out. Whether you keep the kit for your children, your grandchildren, or you donate it to a school, it will help us a lot. And it will also create a passion for learning that will last a lifetime. We really appreciate your support. And I know that your school and community will remember you with gratitude for years to come. Thanks.